Hello, this is a video on simplifying square roots and operations on square roots. It's a series of 15 questions, and we'll just go through each one. First up is the square root of 18. It's not a perfect square. Your job is to find perfect squares that go into it. And so, what would be a perfect square that can go into 18? It would be 9. Rewrite your 18 as a product of a perfect square and whatever other factor you need. So all you did was rewrite 18 as 9 times 2. Why not 6 times 3? It's not a perfect square. Neither one of them. The goal next is to take the square root of each term. This only works when it's multiplication or division between the numbers. This does not work when there's a plus in between the numbers. Okay, great. So the square root of 9, that's a 3. And then the square root of 2 stays as the square root of 2. And that's your answer. Let's do it again for the next one. Square root of 20. Not a perfect square. Perfect squares to go into it. 4. Square root of 4 times the square root of 5. And we'll get that the square root of 4 is 2. And the square root of 5 stays as it is because there's no perfect square factors for that guy. All right, great. Next up. The square root of 36. Well, 36 is a perfect square, and so because of that, then our answer is just 6. When you see the square root, you're asking yourself, what do you square to get that number? Okay, great. So those three are just simplifying square roots. Now we change gears here, and the next group of questions starts the operations on square roots. What we have next is square root of 5 times the negative square root of 2. Kind of like going to work what we did here backwards. We're going to put them under a single square root. They share nothing in common. Neither one of them have perfect square factors, so they can't be simplified further, but they can be multiplied though. Positive times a negative is a negative. And we have rad 5 and 2 together underneath the square root. Nothing else to do but to multiply those numbers and call it 10. Okay. Next up, we have 5 rad 5 times rad 5. These are all multiplied, okay? So you can do them in any order. Let's leave the 5 on the outside, and let's focus on rad 5 times rad 5. Okay? Whenever you have the square root of something times the square root of the exact same thing, what you get out is just what's underneath. And so what we have is 5 times 5, and the answer is 25. Okay, to convince yourself of that, you can put them together in one root. Therefore, you have the 25, but you know that's a perfect square. So, whenever you see matching roots multiplied together, you just get what's underneath. Numbers on the outside get multiplied with numbers on the outside, and then the rads get multiplied together. So now we have the rads of the next question multiplied together. The 3, leave it as a 3 on the outside, and put the rads together in one rad. And just multiply the numbers. We get 3 rad 15. Okay, great. So that's the first 5 questions. 6? First 6 questions. Now, I'm going to go to the next page. Now we're dividing square roots. Same as multiplying, they can be combined into one. First, check and see if they can be simplified at all. They can't. They have no perfect squares that go into them. They aren't perfect squares themselves. So we combine them in one square root. The square root of each can be combined into a single square root. So the division of the square roots is the square root of the division. And now 6 and 2 share something in common. That's a 3 when you divide. So you get the square root of 3 for your answer. Now we could do the same thing with this next one. With these questions, there's not one way to do it. Okay, we can go two routes here. One route would be to simplify the radicals and then divide. And the other route would be combine the radicals into one, like we did above. Reduce and then divide. So I don't know which route is any better than the other. Let's go with combine the radicals. We have 4 over 3. Everything's multiplied and divided, so we can write that as 4/3, and then we can write that as 12 over 16 under the radical, a single radical, and reduce that fraction. And so 12 over 16, 4 goes into both of them. This fraction reduced is 3/4. You have your 4/3 from the outside, and now you have the square root of 3/4. That actually could suffice as your answer, but with the square root of 3/4, we can go a little further by breaking it back up, only because 4 is a perfect square, and we get 4/3 times the root of 3 divided by the root of 4. There's your perfect square. The root of 3 stays, but the root of 4 is a 2. And then instead of calling it 4√3 over 6, you can do some cross canceling. The 4 can turn into a 2, while the 2 turns into a 1. Final result, 2√3 over 3. Okay, and the last one in this set, root of 6 over 5√75. We could simplify the radicals and then divide, or we can combine the radicals and reduce. I think this might be the route to go if the numbers underneath the radical share a common factor. That might be the route to go, and so that's what we're going to do for ours. 6 and 75 share a common factor, so we're going to do that. Now, the 4/3 was easy to write. Now, be careful here. It's going to be 1/5. And then we'll have the square root of 6 over 75. Reducing this fraction, they each share a 3 in common. So when you reduce the fraction, what you end up with is 2 over 25. Perfect square. So break it back up. And then execute the fact that the root of 25 is 5 for a final answer of root of 2 over 25. Okay, dividing two radicals. Okay, so that's the end of this video. I just wanted to not make it too long, so I have more problems to do. We'll do that on the next video. Thank you.